Okay, so 8, this is the last one. It says use any convenient method, and I've been doing that all along. But I do want to show you, if you were asked and you had to do substitution when it's set up like this, I will show you how to solve for x or y and then solve it. I always try to avoid that because you end up with a lot of fractions and you have to manipulate that, and that's always a problem for many. So whenever you can avoid fractions by doing elimination, I do it. This time we will go ahead and do it with substitution, just so you can see it done once if you're having to do it from this starting point. So negative 6x minus 9y equals negative 3. And then, okay, we're going to take this first equation, we're going to solve for y. Okay, so I have negative 2, not negative 2, just 2x plus 3y equals 1. Now, when I move x over, it will become negative. So 3y equals negative 2x plus 1, and then divide by 3, and we end up with y equals negative 2 divided by 3x plus 1 over 3. So you see how we have these fractions. This is the first equation, and this is solved for y. So now that we have this solved for y, we're going to plug all of this in for y right here and distribute, and we'll have one equation in terms of x. So I'm going to take negative 6x minus 9y. Now y is equal to this, so negative 2 over 3x plus 1 over 3. And then this is equal to negative 3. So we have fractions. Now this one will work out really nice because 9 is divisible by 3, so when we distribute, the fractions will be gone. So I have a negative 6x, and when I multiply by negative 9, this becomes a positive 18. 18 divided by 3 is 6, and I have my x, so plus 6x. And then when I multiply by 9, negative 9 times 1 is negative 9 divided by 3 is negative 3. And then this is still equal to negative 3. So the negative 6, positive 6, they cancel out, and so I end up with negative 3 is equal to negative 3. And when your variables are all gone, you end up with a true statement. You have the same scenario where we say that this is dependent. These are the same line because it comes out equal. And so since we already solved for y, it works out really nice. We'll say x is x, this is y, and then x can be any number. So this also is a dependent system, and it's not asking me for the rest. So that'll finish it up.